Welcome to our series of studies that marked science and technology. We're kicking things off with a truly foundational piece of work, a 1993 study by Jang that introduced the world to a powerful system called ANFIS. And believe me, this is one that has shaped the field for decades. So let's start with a really big question, one that has been at the heart of AI research for a long time. How can you possibly build a system that combines the nuance of human-like reasoning with the sheer power of a machine's ability to learn from data? Well, that's the exact question that led to the milestone we're discussing today. Back in 1993, Jang proposed a revolutionary architecture designed to do just that. And that architecture is ANFIS, the Adaptive Neuro-Fuzzy Inference System. The genius of ANFIS is really right there in the name. It's a pioneering hybrid model, one of the first to successfully fuse the world of fuzzy logic, which handles that human-like reasoning, with the incredible learning capabilities of neural networks. It really is the best of both worlds. And look, this wasn't just some abstract concept. ANFIS immediately started solving real-world problems in critical fields like engineering, energy systems, financial forecasting, and even medicine. Its impact has been so profound and so lasting, it was the perfect place to begin our series. So what do we actually mean when we say neuro-fuzzy? Let's quickly unpack that term and see how these two powerful AI techniques come together. We'll stick to the core concepts here, no need to get bogged down in the complex math. On one side, you have fuzzy logic. You can think of this as the human part of the system. It's brilliant at taking our vague, everyday descriptions, words like somewhat warm or very high, and translating them into a mathematical format that a machine can understand. And on the other side, you have artificial neural networks, which are incredible learning structures that get better and better as they process more examples. Now, before ANFIS, a typical fuzzy system was pretty static. It followed a clear four-step process. You'd have an input, a fuzzification step, a rule base, and then an output. But the crucial part here is that the rule base was essentially fixed. It was set in stone. And this is the absolute game changer. ANFIS takes that static, fixed process and makes the whole thing dynamic. It becomes trainable and learnable. That was the breakthrough. So what you end up with is a model that is, as the quote says, interpretable and learnable at the same time. You get the clarity of human-like rules, but you also get the adaptive power of machine learning, all in a single elegant architecture. Okay, so let's take a balanced academic look at the ANFIS approach. Because like any powerful technique, it's important to understand both its strengths and its limitations. The advantages are significant. First, ANFIS produces interpretable models, meaning we can actually understand why it's making certain decisions. It learns from data and optimizes itself, achieving high accuracy even in very complex systems. And, remarkably, it can be very effective even with limited data, which makes it a fantastic tool for research. Now, of course, no system is perfect. With ANFIS, if you have a large number of inputs, the number of rules can grow quite large, which is something to manage. Its performance can also be sensitive to the initial setup, and for truly massive datasets, the training time can be lengthy. But these are known trade-offs for the incredible power it provides. All right, that's enough of the theory. Let's move on to where ANFIS has made its biggest impact, in real-world, practical applications. You see, the real world is often messy and full of uncertainty, and that's precisely where a hybrid system like ANFIS thrives. It's the perfect tool for problems where the data isn't perfect and the rules aren't always black and white. This is why you see it used in everything from energy forecasting and industrial control to decision support for autonomous vehicles and even medical diagnosis. And this brings us directly to how we at CEKA are applying these advanced models today. We understand the power of neuro-fuzzy systems, and we're dedicated to putting that expertise into action. We are actively using neuro-fuzzy models in both our academic research and our commercial projects, leveraging their unique strengths to build high-performance and reliable solutions. Our team applies these sophisticated models across several key sectors, including energy, industrial process optimization, smart automation, complex financial systems, and in the development of AI-based decision support platforms. To give you a very specific application example, one of the areas where we utilize these methods is in predicting the future prices of financial investment instruments. This is an incredibly challenging task that requires both precision and an understanding of nuance. A perfect fit for the ANFIS architecture. All of this to say, we are always open to new challenges and new partnerships. Whether you're in an academic institution or an industrial enterprise, if your work involves data analytics or intelligent systems development, we are keen to explore potential collaborations. Our commitment is to pushing the boundaries of what's possible in these fields through intelligent and collaborative work. Thank you for joining us for this first installment in our series. We invite you to continue the conversation by connecting with us on our social media platforms. We look forward to sharing more insights with you in the future.